Hello everyone, we are going to be working on intermediate algebra support in this video, and we are going to do 9.1. Okay, so remember, this support class does not cover everything that you need in intermediate algebra, but I will teach it to you in a little bit different ways. Hopefully it clicks a little bit better. Okay, our learning target today is a long one. Okay, so we have I can determine if a function is linear or quadratic, and find the vertex, the minimum and maximum, and the domain and range of a quadratic function. Okay, a lot of that might seem confusing right now. I promise it'll get better by the end of this video. So the first thing we need to do is figure out what a linear and quadratic function are, because that was the first part of my learning target. Okay, I can determine if it is linear or quadratic. Well, this goes back to naming a polynomial. Okay, a linear function is a function with a degree of 1. Okay, and this means it's talking about our x. Okay, so if I have a linear function, an example would be y equals x. Now we know that there is an invisible 1 in the power of that x, but we don't have to write it. Okay, another example might be y equals 5x. Okay, still there's that imaginary 1 as my exponent. Okay, we also have y equals 1/2 x minus 5. Okay, again, there's an imaginary 1. That's the only thing we care about. Okay, is there can't be a bigger exponent, and there has to be an x. Okay, a non-example might include y equals x to the third, okay, or y equals 7. Okay, notice how the exponent for x in the first one was not 1. In the second one, y equals 7, there was no x, so that's why it's a non-example. Okay. The quadratic is a function with a degree of 2. So it follows the same rules, except it's going to be y equals x to the second. We're looking for that power of 2. So it might not be in standard form right away. So it could say y equals 5 minus x to the second. Okay, that is still a quadratic function. Okay, and this is what we're primarily going to focus on for this week, quadratic functions. Okay, a non-example, okay, we could do y equals x to the third again. Okay, we could do, let's go back to examples. If I did y equals 5x to the second plus 2x plus 1. Okay, remember we're only looking for that power of 2, and I have it right next to that 5x to the second. Okay, now remember we have to put it into standard form first. So on the second one, if I had y equals 5 to the second minus x, I might think that this is in standard form, or I might think that it's a quadratic because I see a power of 2. However, if I were to rewrite this one, okay, I know it's actually y equals 25 minus x, which if I put it into standard form, it would be y equals negative x plus 25. And I can see that there's no longer a power of 2 attached to that x, so it is not a quadratic function. Okay, so being able to find a quadratic function is super important so that we're not getting confused. Okay. So, and look at this. I even said make sure the function is in standard form. So in your notes, can you please put a box around this and then put a star by it and then underline it? Okay, don't ever forget this. Standard form is our best friend. Remember, our standard form is when I have, in this case, we're going to have like a y equals, and then it's going to be ax to the second plus bx plus c. Now there might not be a value for every single one of these, but it's my highest exponent to my lowest. Okay, I'm going to put highest power or exponent to lowest. Okay. So now let's zoom back out and let's decide, okay? Determine if the function is linear, quadratic, or neither. Okay, so I want you to go through, so the first one is y equals x minus 3. You're just going to circle linear, quadratic, or neither. And I want you to go through all 8 of these problems. Okay, so pause your video and try to do them. Okay, hopefully you paused your video. If not, you guys aren't doing very good at following your directions. But if you paused your video, that's fantastic. Okay, let's go through some of these. Okay, remember, I'm looking for the exponent. What's attached to the x? So in this case, I just have an x. I know that there's an invisible 1, so it's linear. On this second one, find my x. Oh, again, an invisible 1. Okay, I hope that little 2 didn't confuse you. It's linear. X to the second, that means quadratic. Find your x. Oh, this has an x to the third and an x. Okay, so since there's something bigger than 2, I know it's neither. Okay, hopefully that one didn't trick you up. Okay, then I have my x's. I have an x here and an x, and I see x to the second is the biggest, and that's what I wanted for quadratic. And then lastly, oh, this one looks tricky. Okay, well this one I notice is not in standard form, so I think I need to rewrite it real quick. So I know if I have something to the second power, that means I'm just going to multiply it by itself. So I write it once, and then I write it twice. And at this point, you can decide, are you going to distribute or are you going to do the box method? Either is fine. I'm going to go ahead and distribute for this one. X times x will give me x to the second. X times 2 will give me 2x. I'm going to move on to the bottom. 2 times x is 2x. And 2 times 2 is 4. So I will have x to the second plus 4x plus 4. And in this case, look at that. I have an x to the second, so it is quadratic. Okay. If this distribution process is not something that you're remembering, please reach out for some help. Join the Google Meet or come into the school. Okay. So now we're going to look at a graph. Okay. Well, here's the thing. The nice thing about this is the word linear. Okay. If it's linear, it has the word line in it. Is it forming a line? Okay. Remember, it's not going to curve at all if it's a line. Okay. So as I follow my graph, whatever shape they're giving, it's a line. There's no breaks in it, so it is going to be linear. Okay. And this is the one you guys probably don't know. However, okay, it has this curve. This is called a parabola. Okay. So this, let's write that off to the side. A parabola. Okay. Parabola. That's what it is spelled like, but it's parabola. Okay. And this is our function for a quadratic. So I'm going to put x squared next to it. And then I'm going to circle my quadratic. Oops. Okay. So you need to decide, how well do you understand this section? Can you get it the majority of the time, all the time, or do you need to ask? Okay. So the reason that's super important is because we need to be able to identify our quadratic functions as we move forward. Okay. So we're going to talk about a quadratic function. I have the simplest form of a function. Okay. So this is called our parent function. Okay. And for a quadratic, it's y equals x to the second. So what I'm going to do is I'm going to substitute numbers in for this x so I can get my y. And I'm going to start with the easiest number on here, which is 0. If I have y equals 0 to the second power, that's going to give me y equals 0. So I'm going to go over to my graph, and I'm going to plot 0, 0, because my x was 0 and my y was 0. Okay, and then I'm going to go back, and I'm going to do my next easiest number, which is 1. So it's y equals 1 to the second power, which will be y equals 1. I'm going to go graph it. This time it's going to be 1, 1. Okay. And then I'm just going to work my way up. So y equals 2 to the second power. Well, that would give me y equals 4. So when I graphed this one, I went over 2. So it's x was 2 and my y was 4. Where do those meet? And then lastly, this 3, y equals 3 to the second power. That's going to be y equals 9. So it's going to be 3, 9 when I go graph this. Oh, well, it doesn't look like I have a 9 on my graph, so I'm just going to eyeball it a little bit. I know it's going to be up here. Now I need to work my way backwards. Okay? And I always like to start with my negative 1. I'm going to do y equals, instead of just writing negative 1 squared, I want you to put parentheses around it. So negative 1 to the second power. Okay? Because if you type it in differently with this parentheses, it will get you the right answer. If you were to type in this into your calculator, it's going to give you negative 1 as your answer, and that's not correct. Okay? So I need you to make sure that you are using the parentheses in this case, because you will get y equals positive 1. So this will be negative 1, 1. So I'm going to go to the left 1 and up 1. And then I'm going to do my 2. So y equals negative 2 to the second power. Again, use those parentheses. That'll be y equals positive 4. Okay, so as I type that in and graph it, it's going to go right here. Now hopefully you're seeing a pattern and you're like, oh, it's just repeating itself in a positive way. You're correct. So the next one is going to be y equals 9. Okay, so I'm going to find that. Negative 3 and up 9. And I want to connect all my dots, and it should give us a nice U shape. And hopefully you remember, ooh, that was a bad one. Hope you remember that U shape is called a parabola. Okay, so you're going to connect them and draw those arrows at the end. Okay, so now that we've learned about this parent function and what kind of shape the quadratic is, okay, we're going to talk about its concavity. Okay, so I know this might seem silly, but I need you to do something. Okay, I want you to take both of your arms and raise them up. Okay, if you are raising them up, both of your hands should be in the air. Okay, that's concave up. If you put your arms up, okay, if you put your arms up, you should have this U shape. It should be pointing upwards. It opens up. Okay, now take both of your arms, and I want you to point down with them. Okay, now looking at your body, okay, now your body should be forming a U downwards. Okay, that's concave down. Okay, when we have an equation, so we might not always be given a graph, but when we have an equation, we look at the very first number. And remember, we always put it in standard form first. But once it's in, we look at A. If A is positive, it's concave up, so they're going to be pointing up. Okay? Think about if your team is winning, you're very excited, your energy is up, your arms are up in the air. Okay? If you have a negative A, right, then your arms are down, you're sad. Okay? It's negative energy. That is when you're concave down. Okay? So an example of concave up, we already kind of know the picture. It's going to be going any type of way. It's going to be going arms up, arrows up. Okay. Now an example of seeing this in an equation might be y equals 2x to the second plus 4. Okay, again, it's a quadratic function, and that the number attached to the x squared is positive. Now, if there's not a number there, it might be y equals x to the second minus 4. Okay, so that number in the very front is still a positive 1. Remember, that's our imaginary number when there's nothing there. Okay. A non-example of this, okay, so this would be, again, you might have a non-quadratic function. So y equals x to the third plus 4. Okay, that's not going to work. Okay, something else that might not work is if it is y equals negative 2x to the second plus 10. Okay, so even though there's addition in there, the number attached to the x squared is a negative. Okay, graph-wise, it can't point this way, and it can't point this way, and it also can't point this way. It has to be going up. The arrows have to point up. An example of concave down, we already kind of looked at the graph. They're pointing down. Okay. Some examples of this one would be y equals negative x to the second plus 5. Okay, that important number is what's in front of the x squared, and it's negative. Okay. Another example might be y equals negative 8x to the second minus 2. Okay, again, that negative number in the front. Some non-examples, again, it doesn't have to be a quadratic, so it could be y equals negative 5. That's not an example of this. You could also have y equals negative 4x to the third. Okay. So now I want to go ahead and talk about a vertex. I promise this last part of the notes goes a little bit faster. Okay. So the vertex is going to be the highest or lowest point on a quadratic function. So for these three examples, I want you to circle the vertex. Where is, on this first one, it's going to be the lowest point. So it's right here, okay, where it scoops. Okay, where is the vertex? Where is it scooping at? So right here, and then over here, even though it's wider, there's still a scoop. Where's it at? Okay, if I had looked at the top of it, okay, I might think here, well, that's the highest part, but since it's not scooping, it's not doing that U shape, okay, and there would be two options, there's only one vertex, okay, so that's not going to work. Okay. Then we have these next words. Okay, so it was a vertex. Now we're going to talk about minimum and maximum. Okay, so a minimum is when we have a lowest point. Okay, oops. The lowest point. Okay, that's going to be when it's concave. Well, are the arrows pointing up or down? They're pointing up, so it's concave up. We're going to have a maximum okay, when our arrows are pointing down. Okay, so that minimum point is where the vertex is based on it's concave up. So if it's concave up, it's a minimum. If it's concave down, it's a maximum. Okay, so looking at these three problems above, right here we would have a min. On this one, it's concave down, so we would have a max. And on this last one, it's concave up, so we would again have a min. Okay, so when we are looking at the concavity, we want to look at that equation again. So just like before, we look at our A. If A is positive, we will have a minimum. If A is negative, we will have a maximum. Okay, these are it's just going to be a vertex point. So for either one, it's going to set, you would say your min is a coordinate point, okay? And remember, we do x comma y. For a max, you would put max x comma y, but there are going to be numbers here. Okay, so these should be replaced with numbers. Okay. And the last part for today, okay, we need to talk about domain and range. Okay, domain's an easy one. Okay, always, always, always put this. Okay, so always going to put x is included in all real numbers. So see how it's a funky R? Okay, so I want you to draw, let's practice this real quick. Draw 2 lines and then your R. Okay, or draw an R, capital R, and draw an extra line through it. Okay, lots of ways for you to do this. Please practice it. Okay, but this is always how you're going to write your domain. X, this weird E. Okay, this weird E, you're just going to do it like a C and then draw a line through it. Okay, and then we have our domain, or range, sorry, that was our domain. Our range, we are going to look at our vertex. Okay, and if it's concave up, we're going to do y is greater than this coordinate. Okay, so it's kind of like y is greater than y, but we will have a number. Okay, and then here, if it's concave down, it'll be y is less than or equal to that same number. So let's practice this real quick. So on this one, remember what is always our domain? X, this weird E, and then this R. Okay, X, weird E, weird R. X, weird E, weird R. You can do that for all of them if it's asking for the domain. Now for our range, is it concave up or concave down? This first one is up, concave up, so I know it's going to be y is greater than or equal to, and I'm going to look at the vertex. My vertex is right here, okay, and it goes over 1, and because it went over 1, and then it went down 1, 2, 3. Okay, so based on that, this -3 is the number I'm going to use. Okay, so on this second one, it is concave up again. Okay, so find your vertex. There's already a dot here for us. Okay, so if it's concave up, I'm going to do y is greater than or equal to, and I need to find this point. It went over 1, 2, 3, and then it went up and down 0, so 3, 0. So my y in this case is going to be 0. Okay, that's all of our notes for today. Okay, your homework today is to self-assess. Okay, so I want you to look at these. Okay, the first one is I can determine if a function is linear or quadratic. Decide where you are at. Do you not know where to start? Do you think you can start it, but sometimes you get confused? Can you almost always get it right? Or can you teach it to others? Like you know it, okay? So if you are trying to decide between any of these are not changing, but for linear or quadratic, okay, you should be looking at those very first problems we did. So when we decided, was it linear, quadratic, or neither? Okay, so decide, and then just put a circle around wherever you're at. Okay, so in my case, I can do number 4. Okay, the next one is I can find the vertex and the min and max of a quadratic function. So going up to where we did vertex and min and max, that was this page. Did I understand where to put my circle? Did I understand if it was up or down and then min versus max? Okay, so again, where were you comfortable with that? Okay, I am a teacher, so I'm going to put 4. But this one might more realistically be a 2 or a 3. I need to know what we need to practice. Okay, and then our last one is I can find the domain and range. Okay, so this is the last problem, this last page we did. How comfortable are you with domain and range? If you're really comfortable with the domain, but not so comfortable with the range, maybe you're a 3. Okay, maybe you're still not quite sure about the symbols on domain, so you're still a 2. Okay, so circle wherever you're at. Okay, now that you're done, go ahead and turn it in. Okay, make sure you do this self-assessment first.